Back to my channel. Today we're going to work on the question, the longest increasing subsequence. It's a medium level question, and the question states, given an integer array nums, return the length of the longest strictly increasing subsequence. And looking at example 1, if nums equals 10, 9, 2, 5, 3, 7, 101, and 18, the longest increasing subsequence is 2, 3, 7, and then either 101 or 18. So that's 4. 1, 2, 3, 4, or 1, 2, 3, 3, 4. And looking at example 2, 0, 1, 0, 3, 2, 3, the longest increasing subsequence would be 0, 1, and then 2, 3. So that's a total of 4. And if it's all the same number, then it's just 1. So looking at this question, today we're going to solve it using a bottom-up dynamic programming solution. I know so far in my channel for dynamic programming, I've always solved it using top-down. So we're going to do it a little bit differently today. So like all dynamic programming questions, the first part we have to define like a base case. What is the base case for us? So looking at this, if all the numbers are 7, the base, like if we have the same number all together, it's just gonna be 1. So that means we can initialize our DP to all 1s. So this will be our base case. And for the framework of a bottom-up solution, it's similar to a top-down. Like the top-down, the state is passed in as a variable for the recursion, but for our bottom-up, the state is defined in our DP list here. So what this means is that we can initially, the array needs, basically this DP array needs to represent the answer to our problem, the longest increasing subsequence for a given state. So let's say that dpi represents the length of the longest increasing subsequence that end with the ith element. And so this will be our DP and represent each state. And second of all, we need to define like a recurrence relation between each state. How can we transition from one to the other? Let's say dpi plus 1. How can we know when to transition and what's their relation? So basically for this question, we just need to find out if the next number, if it's a usable number, right? Do we use it or do we discard it? So for example, 10, 9, and then 2. By just looking at it, we don't need to use 10, we don't need to use 9. We don't, like 9 we could use it, but it's not the optimal longest increasing subsequence. So we discard it, and then 2, 5, 3, 7, and then we also discard 5, right? But how does our algorithm know that? So let me write the recurrence relation first, and then I'll explain. For pointer 2 in range of 1 to length of nums, this is going to be our fast pointer. For pointer 1 in range of pointer 2. So basically, we go through all the list of nums with 2 pointers. The pointer 2 will be the fast one, so it's going to start at 9 first. The pointer 1 will start at whichever is like before pointer 2, and then we'll compare. So nums, if nums pointer 2 is greater than nums pointer 1, that's what we want, right? Increasing subsequence. Then we can update our DP. So our DP for that state, pointer 2, will be updated. The max between itself, the max between DP pointer 2 or DP pointer 1 plus 1. So if DP pointer 1 is already the longest increasing subsequence that ends at pointer 1, then like to get pointer 2, we can just add 1 to the previous state. That's the recurrence relation. And at the end, we return the max of our DP. So that will be the longest increasing subsequence of the entire nums list. And the time complexity of this will be O, since there's like 2 for loops, it's automatically n squared. And then space will be the space of our DP list, which would be O of n. So this is how I would solve the question, and thank you so much for watching. Let me know if you have any questions.